Good morning and welcome to the South Carolina Public Service Commission. Today is Wednesday, August 25th, 20th, and it is approximately 10 a.m. We are here today for an allowable ex parte communication briefing. It's ND 2025-39-E. All commissioners except Commissioner Britt are here present in the hearing room. Commissioner Britt is in an educational training and will not participate in this morning's hearing. Ms. Moser, if you would, please identify and explain the process for today's hearing.
Yes, of course. Thank you, Mr. Chairman. Good morning, commissioners, and to all who are present here in the hearing room this morning. Today is Wednesday, August 20th, 2025, and we are here in the Commission's hearing room pursuant to a notice of request for an allowable ex parte briefing from the Southern Electric Reliability Corporation, or SERC. The subject matter to be discussed at the briefing today is related to extreme weather and grid hardening. This is the same subject matter to be discussed as was noticed on June 2nd, 2025 for this briefing. This, I would remind you, is a briefing and not a hearing. The briefing must be conducted in compliance with the provisions of South Carolina Code Section 58-3-260D as amended by Act 41 of 2025. The requirements of that statute are, in part, that the allowable ex parte briefing be confined to the subject matter which has been noticed. Therefore, I would ask the presenters, commissioners, and staff to all please refrain from discussing any matters not related to that specific topic. The statute prohibits any presenter, commissioners, or commission staff from requesting or giving any commitment, predetermination, or prediction regarding any action by any commissioner as to any ultimate or penultimate issue which either is or is likely to come before the commission. I would also ask that the presenters, commissioners, and commission staff refrain from referencing any report, article, statute, or documents of any kind that are not included in today's presentation. A copy of any document which is referenced during the briefing must be provided to ORS for inclusion in the record, which will be certified by the Chief Clerk of the Commission, Ms. Jocelyn Boyd. If anyone during the course of this briefing exceeds the scope or does not comply with or fails to conduct themselves within the provisions of South Carolina Code Section 58-3-260, it is expected that a contemporaneous objection must be made. And finally, everyone in attendance today in person must sign in or register. Everyone in the hearing room must also read, sign, and return the form which you were given at the door when you came in today. It is required by law for each attendee in person to certify that the requirements contained in South Carolina Code Section 58-3-260D have been complied with at this presentation. Thank you all for your time and for your attention. Mr. Chairman, the request and notice for this allowable ex parte communication briefing are in order. Thank you.
Thank you, Ms. Moser. Very good. Before we begin, is there anything from ORS?
No, sir.
Okay, while I got you, would you go ahead and introduce yourselves for the record?
Yes, good morning. My name is Tom Filopoulos, and with me is Ben Muschin. We are with ORS.
All right. And ladies, you're here on behalf of Reliability Corporation. I am going to turn it over to you, let you introduce yourselves, and if you would, tell us what you want us to know.
Thank you, Chairman, and good morning. My name is Rhiannon Gomez, and I'm with SERC Reliability Corporation, and I'm here with Heather Polson, my colleague, and she is a senior reliability advisor. She has been in the electric and power industry since 2008, where she was started as general counsel with the Maryland Public Service Commissioners and then she went on to work at FERC, and now she works, her last few years have been at SERC Reliability Corporation with us. And she is a great asset to us. She is responsible for working with SERC's engineers on data validation, conducting research, and writing SERC's seasonal assessments and our long-term reliability assessment as well.
Well, welcome to you.
Thank you. Today we are going to go over just an overview of the ERO enterprise, the Electric Reliability Organization enterprise, which is what we are a part of. We will go over severe weather regarding specifically Hurricane Helene and Winter Storm Elliott, along with the importance of grid hardening and resilience. So to go over, I believe some of you have been briefed on the Electric Reliability Organization, but just to kind of overview. So we are a part of NERC, and we are one of the 6 regions. But to go back a little bit, the history of how we were started. So there was the 2003 American blackout. It was the largest blackout in American history, where over 50 million people were left without power. So Congress responded in 2005, and they added Section 215 of the Federal Power Act, which created the ERO, the Electric Reliability Organization, and gave FERC the authority to delegate the regulatory authority to us. Because prior to that, the regulations were more strongly suggested. There were no repercussions to people or the utility companies not following those recommended those recommendations. So now they are fully in effect. They are mandatory, and each violation, if they do not abide by it or they're found non-compliant, we have the authority to sanction them up to $1.2 million per violation per day. So it comes with great weight, and we hold that responsibility very highly, and so do the utility companies. To go into, as you saw, there were 6 regions in NERC's, the ERO. We are in charge of the Southeast. So we have the largest amount of states, which is 16 states in our footprint. We do the 97 plus million estimated population within that region, along with, we have 300 registered entities who we regulate. And within that is about over 118,000 miles of bulk electric system transmission lines. So that produces, we also have 3,400 generating units and the 261 gigawatt forecasted load for 2024. So that goes into our mission. So the Electric Reliability Organization enterprise. So our mission is solely the reliability and security of the bulk electric system. We do understand that you have other considerations such as environmental factors and cost factors, rates. However, our focus is solely the reliability aspect of the electric grid. And we are unique in the fact that we are completely objective and an independent resource. We have no assets, no stake in the game. There is nothing about anything we do that would resolve under any kind of bias one way or the other. We really are, our mission is the reliability of the electric grid. And that is what we regulate. So I will turn it over to Ms. Polson.
Thank you so much for allowing us to come here today and to let me talk about my passion, which is the reliability of the grid. I've devoted 15 years of my life to it, and it really is my passion. I know as a former general counsel to a state commission that you have to have expertise in a great deal of things that you may not have background in, right? So, and you also don't necessarily get the resources to have, a huge amount of staff to back you up for all of the demands that are made on you. So we're happy to be a resource to you, but also I wanted to say that if I use some jargon or I say something that's confusing, please just stop me and interrupt me. It's because we want this to be useful to you. I don't want to just be, saying things that aren't useful to you. So please just jump in. So you can go ahead to the next slide. So jumping right into Hurricane Helene, which I know is still very much front of mind for so many of us. This is just a look at the transmission line outages. Now I know distribution was also a huge deal. That's what directly affects the households and is what kind of gets cleaned up last and often takes a lot of the time, but it's not what we have jurisdiction over. So this is what we focus on, goes all the way down to the 115 kilovolts. Where there was a great deal of damage at that level. But even at the biggest lines, the 500 kV, there were 7 out, which is just pretty astonishing to have 7 500 kV lines out. And 230 kV, 38 of those out. I mean, just tremendous amount of damage to the transmission system alone, notwithstanding how much damage we know there had to have been to the distribution system. And we're going to talk later about, obviously, they got this fixed with a tremendous amount of help, from others. So you can go on to the next slide. And this is just some of what Mother Nature threw at South Carolina as compared to other states, obviously wanting to focus on South Carolina. The peak winds that were registered, that they could have been worse. This is just what was able to be, recorded, where there was recording devices, ranged from 63 to 67 miles per hour. And there were pockets of rainfall from 10 to 15 inches, and then 18 inches plus in northern Pickens and Greenville County. And then just wanted to compare this to the North Carolina mountains. Not to, I know there's competition there, but just because we know there was a special amount of destruction there. They had 20 to 30 inches. So not that y'all didn't have, I know there was a lot of destruction also in South Carolina, but just to get a kind of a bit of comparison there, the high end in South Carolina was comparable to some of the beginnings of the worst in North Carolina as well. Next slide, please. And this goes into some of the outages, which I'm sure y'all were aware of at the time, your peak outages, but approximately 1.4 million and 49% of the total customers, according to the data we have, which again is just an astonishing number. Nearly half of your citizens with no power at one time. I know that y'all were clearly hearing about that at the time, and just an astonishing thing to have to deal with. Had some more of a breakdown on this, that, Dominion, South Carolina had over nearly 400,000 work, and they had 2,700 workers out there working on it. And Santee Cooper had 6,700 retail customers out, but they also had 48 transmission power lines locked out because they serve a lot of co-ops, as you know. So that really had to impact their customers a lot. And then Duke, which, as you know, doesn't divide evenly South Carolina to North Carolina. So, but they had over over a million, like 1.4 million customers out, and they had 21,000 workers going in North Carolina and South Carolina. Next slide, please. And I mentioned earlier that I would talk about kind of the help that they had. So wanted to talk about mutual assistance, because this is one of the things I always find most inspiring, during and after hurricanes, is mutual assistance, where they always help each other out. And I moved to Charlotte from Baltimore, and being right on 95, I would always see the convoys of the workers getting in place before the hurricanes, and you would just see these long just trails of truck after truck after truck going down with all different utilities on them, but in one big convoy. And I would tear up, honestly, no lie, because I love it. I just love how there's really no other industry where they just get together and help each other like that. And in this event, Hurricane Helene, they actually had 50,000 personnel from at least 40 states in District of Columbia and Canada that assisted overall. So just, it was one of the largest mutual assistance mobilizations ever. So again, I just think that it's so inspiring. Next slide, please. So do you have any more questions about Helene that we can answer? That's kind of what we had for you on Helene. We did, we did follow it, but again, mostly from the transmission system side because that's our jurisdiction. I know y'all's jurisdiction is more distribution, and that is usually where much more of the outages are. And so I'm sure you had an even bigger headache than the numbers that I showed to you, other than the one about 49% of your citizens being out. That's probably does reflect a number that you really dealt with.
I have a question, Mr. Chair, if I may.
Go ahead.
Yes, sir.
Good morning, ma'am. Thank you for being here this
Sure.
morning.
Thank you, sir.
How do you all work with the utilities?
I mean, we work with them in many different ways. I mean, one of the ways we work with them is we have a whole committee structure within SERC that we have committees, subcommittees, and working groups that are devoted to many different topics. And that's the way that we get, I would say, the majority of our work done. We also, can do ad hoc things. We also work with them on enforcement if need be. So what Rhiannon talked about, if there's a violation of one of the reliability standards, we work with them on, okay, we've identified a violation, then we try to work out a resolution to that, a settlement, and then as part of that, we have mitigation. How are you going to fix this and make sure it doesn't happen again? So those are some of the ways. Some utility members are on our board, but our boards are mixed because we also have independent members to make sure that we're not dominated by the utilities and therefore not independent, not able to give you, independent advice. Those are a few of the ways that we work with them.
Okay. Thank you for sharing that.
Sure.
As I'm sure you know, we have so much going on in our state that it keeps us pretty busy.
Yes, sir.
And maybe I should know this, but even if I do, it's not coming to my memory right now. The reason I asked you that question is I wonder whether or not there are any recommendations that are being made to the utilities regarding hardening of the grid to support reliability, whether that's for winter storms, tropical storms, wildfires, just any extreme weather event.
Sure.
And the reason that comes to mind is interesting, the timing of you all's presentation. My wife the other day asked me about or told me about some Netflix special that she's watching regarding Hurricane Katrina.
Oh, yeah.
And apparently
Yes,
there
sir.
was all type. I haven't watched it, but apparently there were a lot of recommendations made. And this, I don't know how true this is, but according to her, a lot of recommendations made literally a year before Katrina, and all of them were ignored. And then you have Hurricane Katrina, and like, how do we get here? And then,
Right.
20 years later, we're looking back, and it's so easy to Monday morning quarterback, and hindsight is always 20/20.
Sure.
But at the very least, the recommendations were made.
Sure.
They were not followed, and then
Right.
you have a catastrophe,
Right.
even more so than it had to be.
Right.
So I'm just wondering whether or not you all are making recommendations to prevent just the worst outcomes from
Sure.
storm events that seemingly keep coming.
Sure. No, that's a great question. And especially as to winter events, there are a lot of recommendations out there in the joint FERC-NERC regional entity reports, of which there are four. Well, there's three that relate to the winter. There's one that was a a shoulder season event, so that would be a little bit more relevant to summer and shoulder season events. But there's 3 winter events, and those are very relevant to winter events. And then there's a lot of recommendations in those, and whether they've all been followed, I would dare say they haven't all been followed. I think a lot of them have been, though, and some of them have been put into mandatory standards, especially as to the generators. A lot of them have been put into mandatory standards, which is good. That was something we really pushed for, because a big part of the winter events that were happening, like Winter Storm Elliott, was generators freezing, which we're going to get to in a minute, but I'll jump ahead. Generators freezing, and therefore that was kind of the beginning of this chain of events. And so we said, well, we need just mandatory standards on generators so that they can't keep freezing up like this. So that has happened, and so that is at least one thing that we took out of the voluntary realm. So that's been a good development. So that is one area that I realize I'm mentioning a report now that's not in the record. I can get those into the record, I guess, by, I don't know, can I email those to somebody?
I'm not asking for them.
Okay.
I'm not asking
Okay.
for them.
Okay.
What I'm
They
trying
exist. They exist, though.
Okay. What I'm
Those-
trying to do
yeah,
is
sorry.
get an understanding. I mean, I pray to God that we have no more extreme weather events. But again, they seem to keep coming.
Sure.
They seem to be a known. And unfortunately, not only do they cause property damage and discomfort with outages, sometimes people die.
Correct.
As you know.
In Texas, yes. Anywhere from 200 to 800 people died in Texas.
And so we know that happens. Today, we know that happens, right? And so in my mind, just the way I think, I would want to make sure, if I had the responsibility to provide safe, reliable service, I guess you can throw affordability in there, if you will. And I knew that storm events, extreme storm events, seem to come at least once every couple of years. I would want to make sure that I do everything I can to not only provide that service, but to make sure that my infrastructure is hardened in a way that hopefully prevents catastrophe, including death. Now, it's hard to be, I mean, you can't be perfect. It's hard to be perfect, but
Sure.
I can imagine it's sort of uncomfortable to come to our hearing room for a utility to come in after the fact and then try to explain why we suffered, if any were suffered, outages, extreme outages, maybe even deaths. And so if you're telling me that there's some recommendations out there that you all have made and that you track whether or not they're followed, that's just helpful information to know. At some point, if we ever need to pull, maybe we do an additional or separate educational session about some of those specific recommendations that you all are making, if that makes sense.
Yes, sir. We could do that. And then as far as hurricanes, I know we have some advice about hurricanes on our website. I would have to look at that to see exactly what the extent of specific recommendations are there, because that's a little bit less my bailiwick. I know we do have specific information out there about hurricanes with some tips on it, but I'd have to see whether any of it specifically relates to hardening. I would have to check on that.
Thank you, ma'am. That's all. Oh, I'm sorry. Go ahead.
No, just to add, we would love to come back and give you a presentation on that. That would be very interesting, I think, to see. But just to answer your question, so when we do, so that's kind of the process. Now, grid hardening and extreme weather, it is, I know 2020 is obviously, in hindsight, everything you can see clearly. However, we are dealing with an issue that is just getting worse and stronger, extreme weather, I mean. That is the trend. So that we're kind of dealing with not only a changing grid, but also a changing extreme weather environment. So keeping up with those things while we do have recommendations, once we see that they either are not being followed due to costs or different, utility companies have many reasons why, they structure things the way they do. We then absolutely make them mandatory. So that there is a process to that, and we have to, kind of determine and make an argument for it to become mandatory. So there is a process for that, but that would be a great session that we can follow up with to provide an educational briefing to you on.
Thank you so much.
Thank you, Vice Chair. Commissioner Cass.
Thank you. Good morning.
Good morning. Good morning.
I noticed on, I think, the second slide, under the regions part was page 2. Have the authority to audit and enforce, and it says the regions also provide studies, assessments, and evaluate reliability. Is that what you guys do, SERC does? And in those studies, assessments, evaluate reliability risk, now, do you physically, like after Helene, after Winter Storm Elliott, after events, do you physically go out there and look at stuff and evaluate it, or do you rely on the information received from the area utilities or emergency preparedness folks? I mean, how do you do that?
So mostly we do our seasonal assessments and our long-term reliability assessment. The post-event assessments that are done, normally those are done by bigger groups, like I mentioned, FERC, NERC, and all of the regional entities together, doing the ones about like Winter Storm Elliott, Winter Storm Uri, those really big events. So those usually happen with really big. So before when I was at FERC, I used to be like a co-lead of those, and those are really big teams of like 50 people across the whole country to lead those, because those are super resource intensive to really get all of that data from entities all across the country and then get to the bottom of it. We didn't. I'm trying to think if we did any kind of an analysis post Helene. I mean, we did gather sort of data about just kind of what happened to it, but not specifically. We didn't go out into the field. I think maybe what you're asking is, did we go out into the field and look at the damage and that kind of thing? We did not do that because I mean, we know hurricanes are destructive. I mean, we know that's true. So we try to focus on preparing our entities ahead of time. We give them information in our summer assessments, which come out before the summer. We give them weather to predict how many named storms are going to happen. Is it going to be a more intense year than usual, less intense year than usual? Is it supposed to be hotter than usual, more precipitation than usual? We give them weather information like that. It's things like that we try to give them, as well as whether they're supposed to have enough resources to get through the season, things like that. Those are the kinds of things that are in our summer assessment.
Okay, thank you.
I could add to that.
Sure.
So the more boots on the ground, I think, is what you're looking for. So what we do regularly is we do audit. We audit the utility companies. We give them notice of those audits, and then so that's our SERC employees going to the utility companies and doing audits to make sure they are compliant with whatever the audit has the scope of. We also, if there are major events such as a load shed, which could require an investigation, then that's when we do get involved and we investigate an event that leads to potential then a violation and a sanction.
So from like these studies and assessments, does SERC, you guys or whomever there, do you do like a forensic analysis to, for example, these transmission lines washed out or were taken out by this or that, Is that what's done with these assessments or studies or?
If it's mysterious, yes. But if a hurricane tears out a bunch of lines, then it's not mysterious why that happened. So then that we wouldn't normally do that kind of analysis there, because everyone knows why you lose a bunch of transmission lines when a hurricane comes through, because the effect of wind on on lines is well known. Now you certainly can encourage people to harden their lines, because that will make more lines be able to survive the high winds. But it isn't as mysterious as when you have like say the 2011 event out west, where they had a cascading outage where San Diego blacked out in a matter of 10 minutes, and originally we had no idea why, and it was a complicated series of cascading outages that started with one 500 kV line tripping, and you sort of had to piece it together. Why did this happen? So I guess I'm just trying to make a distinction between where it's mysterious why it happened and where it's clear that Mother Nature was the villain. It's clear who the villain was. Mother Nature was the villain. So not to make light of it, because there's nothing light about a hurricane and all the destruction and death that it causes, but just that we do know who the villain is in those cases. It's Mother Nature.
And that's good enough, because I was thinking about what Commissioner Justin Williams was asking Vice Chair, relative to hardening and such, and I was thinking, well, I guess that forensic analysis, or going back and looking at what happened, why, hurricanes, I assume 100 mile an hour winds aren't good for lines, or whatever, that is the information that's taken to. Well, I don't know that you guys determine what should be hardened, what's not hardened, but these are the things that happened, and this appears why. That, in essence, is what these assessments and all do. I'm taking it.
Yeah, I mean, we did not, to my knowledge, go out and do a special assessment after Helene, but I'm not in charge of the. So we do have one part of SERC that does what's called event analysis, and it's possible that they did some sort of an event analysis after Helene that wasn't, isn't quite assessments, because our assessments are like the irregular assessments that we do, like the summer assessment, the winter assessment, the long-term assessment, and then we have a risk assessment that we do. So those are our regular assessments that we do on like a cyclical basis, and then so that other area, they could have done something where they maybe looked into it just on an event analysis basis. It's possible that they did do that.
Thank you both so much.
Sure. Thank you, sir.
Thank you, Commissioner Gaston. Commissioner Williams.
Good to see you all. Thank you for being here. Thank you to my colleagues for their questions. I'm going to pose my question, but I think I know the answer based on the conversations that we've had. But when I looked at the transmission line and the impacts, what I thought about were, I know there's the pressure to rebuild as quickly as possible and bring everybody back online. I'm wondering about lessons learned through that. Were there the ability to harden as a part of that if you had the right materials? Was there assessment in terms of, was it footings? Was it structural? Were they the lines? Because I was called on, I went ahead and asked that. It sounds like that's not what you're here to talk to us about, but that would be really interesting if your that team that you talked about that might have done something like that has information on a broader perspective
Sure.
to learn from.
And I do believe that there were some, lessons learned presentations that we got from utilities, like, shortly after, I do remember that, that being a thing. I don't know exactly how many, so I mean, we certainly can ask about that.
Yep,
Thank
we do have the end-event analysis team, and they do an analysis on major events. So we can come back as well with that with one of those team members to go over in more depth if that's something you'd be interested in.
Okay. Thank you.
Thank you, Commissioner Williams. Commissioner Thomas.
Thank you. So you had mentioned the companies coming together and helping, and people coming from all over the place to help. Does your organization have anything to do with helping to make that happen, or is that they just do that on their own?
They just do that on their own. That it's a long-standing tradition in industry, but I just like to tout it because I think it's great.
Yeah, it's impressive for sure. All right. Thank you. Appreciate it.
Thank you, Commissioner Thomas. You may proceed.
Thank you. So going from hot weather to cold weather, Winter Storm Elliott, and you can go to the next slide, please. So Winter Storm Elliott, one of the big problems about Winter Storm Elliott is obvious from this picture. It pretty much covered half of the country with extreme cold weather, and you can see that some of the darkest and even the purple areas here, it was as 30 or more degrees below the normal low temperatures. So this was a pretty extreme cold, and it turned cold very quickly. It went from relatively normal temperatures to this extreme cold in the space of a day. So that's also extremely bad for machinery, especially does not take well to that. Although the period that we looked at stretched from December 21 through 26. The worst days really were like the 23rd and the 24th. And overall, it had estimated losses of $5.4 billion, and it left residents without power throughout the southeast and south central U.S. At various points for 2 days. And it was the largest controlled firm load shed in the history of the Eastern Interconnection, which covers the eastern half of the United States. And the Eastern Interconnection is normally a part of the United States which does not have load shed because it has a lot of power, and it has a lot of entities that are able to share energy with each other. So if one entity is short, it can always get emergency power from another entity, because it's just such a huge interconnection that even if there's trouble over here, this person over here has got energy because it's just such a large area. But again, you can see the problem just from looking at this picture here. That weather covered half the country. So whoever you were looking to get emergency power from, guess what? They were under the same storm as you, and that was basically the problem. So in total, the amount of firm load shed, or what we kind of normally would think of as rolling blackouts, was over 5,400 megawatts, although not at the same time, but that's a pretty large amount of load shed. Next slide, please. And then focusing in on the natural gas situation, the dry natural gas production in the lower 48 states dropped to a low of 82 million cubic feet on December 24, and this was a 16% decrease overall for the lower 48 states from December 21. However, the greatest declines were seen in the Marcellus and Utica shale formations, where production dropped by 23 and 54% respectively. And unfortunately, these are kind of the key formations right now, where a large portion of the U.S. relies on, and especially the area within SERC relies on for their natural gas. So it really did put a hurting on SERC entities for getting their natural gas. Next slide, please. So this slide focuses on the generation that was lost during Winter Storm Elliott. And I know maybe some of that type's a little bit small, but I'll try to read everything that's important here. So these are the incremental unplanned outages, and that means that it's anything that was over and above unplanned outages that were existing when the storm started on December 21. And at the worst point during Winter Storm Elliott, there were over 90,000 megawatts of unplanned generating outages at the same time, outages, derates, and failures to start. And this, however, is not just breaking down those 90,000. This is breaking down every single outage, derate, or failure to start that occurred between December 21 and December 26. And so if we look at this, we can see that 31%, or not quite a third, were still from freezing issues. And these have been one of the top 3 causes in all of the 5 major winter events that have been examined by reports going back to 2011, although some progress has been made over time in chipping that down somewhat. And then natural gas fuel issues accounted for 20% of all these generation outages and derates, et cetera. And that's in large part due to freezing issues with natural gas infrastructure, which is a big problem. And then this 41%, which is kind of the big gray pie piece, that's due to mechanical electrical issues. Those are correlated with cold temperatures, meaning that they get bigger as the temperatures drop. And this suggests further avenues for research to prevent those losses. For example, we speculated in the report that they might be like materials issues, or oil getting too cold and that kind of thing. So definitely, one of the recommendations was to do further research on that. Next slide, please. So I mentioned earlier that although it spanned from the 21st to the 26th, that there were a few days that were the worst. And Christmas Eve, unfortunately, was the worst day. My own pipes broke, and I woke up Christmas morning to a waterfall in my bedroom. So I don't know, but probably a lot of us have stories about Christmas Eve that year. So it was the worst day for many areas, including South Carolina. And 8 balancing authorities, which are the entities on the grid that have to balance in real time, the energy, and then what generation is the energy that generation is producing, and then the demand from retail as well as, households and that kind of thing. They have to balance that every minute in real time. So that's what balancing authorities do. So 8 of the balancing authorities, including Dominion, South Carolina, and Santee Cooper in South Carolina, were experiencing energy emergencies. And energy emergency is just a term from the NERC reliability standards. There's 3 levels. So energy emergency 1 means that you've used up all of your available generation, so you're getting tight. It's kind of scary, but it's not the scariest thing yet. Energy emergency 2 is you can't provide all of your needed energy, but you haven't cut into your reserves yet. And then energy emergency 3 means firm load interruption, again, rolling blackouts, is imminent or in progress. So those are the 3 levels. So 8 of the balancing authorities were in 1 level of those energy emergencies. And then 5 of the 8 actually had to shed firm load. So that means they got all the way to level 3. And the widespread nature of the energy emergencies meant that your neighbors, which normally might provide you emergency energy, were unable to assist, as I mentioned earlier, because of how big this storm actually was.
Ms. Polson.
Yes, sir.
Was there any thought, or looking back at it, that the fact that this happened just before a holiday, it seemed like there was things just kept going wrong for some of these companies and all. Was there any thought about the reason was because it was holidays and people were off and not properly staffed? Was that ever an issue that was discussed?
Well, actually, most of the utilities did. If in the big report that we wrote, one of the things we write about is what were the preparations that they made for the storm, and this storm was predicted a long way out, as most of these cold weather storms are, able to be predicted quite a bit ways out, and so most of the utilities actually did have a lot of a lot of extra staff on, because they knew that they would need it. And then quite a few also did commit all their generation, for example, early so that they could get gas, because getting gas on a holiday is a problem. And that has been something that has tripped people up in the past. So they did commit their units so they could get gas over the holiday weekend. But then what happened is the gas just freezes up. And even if you had bought gas, and even if you maybe even had firm gas, if the gas freezes up and the gas, no gas coming into the pipelines, I mean, the pipelines just declare force majeure. Even people with firm can be cut off with force majeure. So you can do everything right and still not have gas and not be able to perform if the natural gas isn't coming into the system, which is definitely part of what happened.
Okay, thank you.
Sure.
Just to add to that, Chairman.
That is a good question.
Yeah. If you guys haven't been to a control room, it is an amazing thing to walk into and see. We do them as a staff. We go to them because it's important for us to know, who we're regulating and see what they're doing. But they are in there 24/7. There's always a controller, an operator in there, and we went to Duke specifically, one of Duke's, and they are there. It's a dark room. It's everything's projected on the screens. There's always people in there. They take 12-hour shifts, so it's definitely not an issue of them not having enough staff in there. They are very on top of all the utilities are. They're really great about that. So, and like Ms. Polson stated, if anything, they have the foresight, and they actually add extra staff. So that's something that we're all take very seriously. Even our staff, we have a room dedicated with screens around the whole room where they're monitoring these bigger weather events. So it's just things that, Mother Nature, you can't control necessarily, but lessons learned come from them. And we hope to then do the grid hardening and get better from each time there is sort of a weather incident or catastrophe.
Well, and their reporting to us was very prompt as far as keeping us. We got a couple of letters that explained what was going on, particularly in the last storm. They were very responsive, and so as far as letting us know what was going on, then I'll give them a lot of credit for that. Thank you.
Sounds like they're learning lessons learned. Oh yeah, and I'm sorry. Duke Energy Carolinas and Duke Energy Progress, again, although they're split, they also did shed some firm load as well. They shed, Duke Energy Carolinas shed 400 to 1,000 megawatts, but obviously not all in South Carolina. And then Duke Energy Progress from 600 to 961 megawatts. And again, all of that was on Christmas Eve. So you can go on the next slide. And as we always do in those big reports, the NERC Regional Entity reports, we make a bunch of recommendations, but I just wanted to focus on that there was recommendation for states that state regulatory entities that have jurisdiction over natural gas infrastructure reliability take action to establish reliability rules for natural gas infrastructure necessary to support the grid and natural gas local distribution companies in 3 areas: cold weather preparedness or freeze protection, regional natural gas situational awareness, coordination and information sharing, which would be similar to the electric grids, reliability coordinators, which see the big picture, oversee large areas, and see the big picture, and can kind of foresee problems coming and get ahead of problems. And then finally, designating critical natural gas infrastructure so that it can be prioritized and protected during electric load shed. So this third bullet, I just wanted to explain that after Winter Storm Uri, on the electric side, we took action in the reliability, the mandatory reliability standards that Rhiannon talked about, to protect critical natural gas infrastructure from having its power cut off during these rolling blackouts, because that was a problem in Winter Storm Uri. There was some critical natural gas infrastructure that had its power cut off and made things worse, kind of contributed to just a bad chain of events. But now the grid providers need to know, well, what is the critical natural gas infrastructure so we can protect it, and we need help from the gas side to help us know what that is. So that's what the third bullet is about. And so even if you're a state that doesn't have maybe a ton of maybe at least you don't have the natural gas production, you maybe can't help with the first bullet as much, to do the freeze protection of the natural gas production facilities. You still could be active in NARUC and encourage those other states that are the big producers to, to help with this. Next slide, please. So now, first I would just ask, are there questions on this area before we go on to the next?
Keep going.
Okay, thank you. So, grid hardening and resilience. Next slide, please. So this picture might seem a little overly complicated because it was made by government bureaucrats. Well, not really, but government contractors at least. But it's one attempt at distinguishing between resilience and reliability. It was prepared by one of Department of Energy's national labs, and it finds resilience to extend to protecting and preventing up to the point of what they call a system fracture. And they give some examples of what a system fracture would be, like a sustained outage or a blown fuse. That's where it has a little black, star thing. That's the system fracture. So everything before that is like the resilience domain. Well, between the event and then the reliability domain is the resilience domain. And then after that, it becomes the reliability neighborhood instead. I just thought that was helpful because there's a lot of, I think, confusion sometimes between reliability and resilience. And I thought that was helpful, so I just thought I would share it. But next slide, please. So now what is grid hardening? If you think of Venn diagrams, which I love Venn diagrams, I think they're really helpful to me to kind of think about things. But grid hardening would just be like a smaller circle inside the resilience, bigger resilience circle. So it's a part of resilience, but it isn't all of resilience. There's other things within resilience that aren't grid hardening. It's one type of resilience measure. So it includes things like upgrading poles, conductors, and transformers and substations so they can stand up to severe weather and cut outage time. And then it works with other resilience measures. Next slide, please. And then I wanted to share, in case you didn't know about these DOE resilience grants, they're still ongoing, supposed to be ongoing. Last I checked, they hadn't taken them away online yet for another year. So they had announced by October 2024, they had announced grants of nearly $3.5 billion under this Grid Resilience and Innovation Partnerships Program. And I found at least one South Carolina entity that received over $4.6 million toward an $8 million project. And then there's also a grid resilience state and tribal formula grant program to strengthen and modernize against wildfires, extreme weather, and other natural disasters. I gave when the applications are generally due in June, and it looks like the announcements for the next cycle should be in December. And also pointed out that the website has good case studies about grid resilience and hardening projects for various hazards. And I gave the website for that, and that is where I found the one of the case studies that I'm going to talk about in here. So I'm just going to talk about 2 grid hardening case studies here. One is Florida Power and Light. That is just based on they're one of our entities within SERC, and they just came to us directly and gave a presentation about what they had done and how well it turned out for them, because they were understandably proud of it. So that's what this one is based on. So they obviously faced some major risks, such as hurricanes, and perhaps less obvious, although when you think about it, it makes a lot of sense. They also had increased rate of vegetation growth due to frequent rain and ample sunshine. And why is that a problem? Because you guys probably know this, but most normal people don't know what a huge enemy, vegetation growth is of the grid. It's one of the biggest enemies that the grid has, vegetation growth. So Florida, it's an even bigger enemy because their vegetation just grows so much faster than everyone else's. So after the 2004-2005 hurricane season, which was especially disastrous for them, they decided, we really need to get serious about this, and they just dug in and began a serious resilience program aimed at meeting both of these challenges. Next slide, please. So their improvements including moving their lines and customer service underground, and then hardening their lines using metal or concrete poles instead of wood, up to so by 2022 they had done 94% of their transmission lines, and by 2024 they're up to 96% of their transmission lines. And then inspecting 100% of the distribution poles and replacing those that no longer meet their industry-leading standards for strength. They inspect approximately 150,000 of their distribution poles annually. And then adding real-time flood monitoring to over 200 substations, more than doubling the miles of the right-of-way that they maintain and trim annually, and adding smart grid devices to transmission lines that can help more quickly locate and diagnose problems with those lines. So next slide. So then what happened? What were the results? So their underground lines perform 50% better day to day than their overhead lines, but 85% better during a 2017 Hurricane Irma. The daily reliability improved 41% since 2006, based on SAIDI, which you guys are probably familiar with, the System Average Interruption Duration Index. And then the average time that a customer experienced an outage reduced from 79 minutes in 2006 to 47 minutes. So not quite halved, but pretty close. It's an amazing reduction. And then in 2022's Hurricane Ian, they lost 0 transmission structures, which is an amazing improvement. And the underground lines performed 7 times better in the Southwest Florida than overhead lines. And they estimate that they avoided 400,000 plus outages in Hurricane Ian due to smart technology. And the average customer outage was reduced from 3.5 days to 1.5 days in Category 4 hurricanes when they compared a 2004 Hurricane Charlie, to 2022's Hurricane Ian.
Chair Powers,
Commissioner Cass.
if I may,
Yes, sir.
and I looked back to make sure I hadn't missed it, but the underground lines you were referencing, do you what percentage of that is that transmission lines, is that distribution lines? What percentage of
I
that?
don't. We could ask for that from Florida, but I don't have the breakdown with me.
I just
sir.
wanted to make sure I had not overlooked it,
No,
but I
sir.
was just kind of curious.
Yes, sir. We could get that though, but I don't have it with me.
Well, I'm assuming you have all this stuff in your reports somewhere. And
Well, this was a presentation that they made to us, so I don't specifically have it. I would have to get it from them.
thank
But
you.
I could easily. But
I appreciate that, but
okay,
I was just curious.
okay,
Thank
no worries. Thank you. Next slide. And some of the other things that they do for resilience is they have pre-storm drills every year, and they actually do a fake hurricane every year. That it has a name and everything. That they do a whole fake hurricane drill every year, and then they have their mutual assistance and restoration contracts in place every year before the start of the hurricane year. They have pre-planned staging sites for all the equipment and personnel, and then they stock all the pre-storm equipment inventory that they need well before the season. Next slide, please. So this is the second case study that I want to do, and this one is from that DOA website that I mentioned, and I'm sure a lot of us also remember Superstorm CND, or they call it Tropical Storm CND, that happened back in 2012. And I remember seeing the images of the subways totally flooded out during that, which just kind of shocked me. And it caused unprecedented damage to Consolidated Edison, or Con Edison's infrastructure, which Consolidated Edison provides electric service to all of the boroughs of New York City, including Manhattan. And the storm surge caused flooding and failure of a substation, which left over 220,000 customers without power in Manhattan. And then after the power was restored, the New York Public Service Commission, working with Con Edison, formed a special multi-stakeholder storm hardening and resilience collaborative. And this collaborative produced, among other things, a risk assessment and prioritization model and a cost and benefit model that was adopted by the Con Edison storm hardening planning. And this, just to go off the side a little bit, it was just kind of an interesting thing that they did, because it was somewhat of a non-adversarial model that they used for it. It was a collaborative rather than the adversarial model, to try to enable the storm hardening to happen more quickly than they thought it would happen with the adversarial process, and to enable more of the money to go towards the storm hardening rather than a drawn out fight over, an adversarial process. So they really tried to get the parties together to agree to this, and to agree to how are we going to do the prioritization and the cost benefit. And so it's a really interesting, I think, scheme that they came up with to do this. So next slide, please. So then when the model was agreed to, then Con Ed used the model, and Con Ed and the model used the model, and they determined that out of more than 100 projects, hardening this East 13th Street substation was the highest priority project. And then they re-engineered this substation to a higher standard of flood risk protection than they had previously used, which was the FEMA base flood elevation plus an additional 3 feet. Next slide, please. That's just a picture. You can see from that, you can see from that picture how close it was to the river. You can imagine why it might have flooded. So next slide. And this is just some of the improvements included: installing internal removable flood barriers, sealing penetrations in the control room and elsewhere, relocating the important relay cabinets near the transformers, using microprocessor relays and fiber optic connections, isolating critical controls and circuits in transformer control cabinets, and then elevating some of these critical controls, including the control cabinets in the pump houses and cooling plants, and elevating the control room, the control pump house and cooling plant cabinets, and then the diesel generators, getting all of those to be above the flood elevation, and then upgrading and replacing the transformers. So next slide, please. And then this, before, I had this slide before we knew we needed all our citations on there. So I wanted to make sure that you had the link to the full case study so that you could read the whole thing at your leisure, because I thought it was really interesting, but I tried to hit the high points for you.
And lastly, I would like to, again, thank you for your time, but also mention that we are hosting a Electric Reliability Policy Summit in Charlotte. It'll be at our headquarters, and it will go over, it will be very informative. It will include different panels regarding some of the top risks that we've identified in our the SERC region, which includes South Carolina, one on supply chain constraints, resource adequacy. So we have excellent panelists, and we would love for you to come. We will have a live podcast as well going over, that topic will be over wildfires and their effect on the grid. But all of you are more than welcome to come, and we would love to have you. And it is worth 6 North Carolina CLE credits as well for lawyers. So that is another thing. So it would be very educational, very informative, and we really hope that you guys will be there. So again, thank you so much for having us.
And
Thank you
also
so
any
much for being
questions
here.
on
It's
our
been-
last topic, I guess, as well.
It's been very informative, and I appreciate you coming here and going to the trouble of putting this presentation together. Are there any further questions from any commissioners? All right, again, thank you so much.
Thank you
Anything
for
from
having us.
ORS before we?
No, Mr. Chairman.
All right, then we are adjourned.
Thank you.